Now let's add some detail to make our fidget spinner unique. If we simply double click the view, it will take us back to the assembly. And what we want to do is start modifying the plastic part. So I'm going to edit that part in place. If I click Control Q, it will turn off the background parts. And now we're ready to go and just going to project to sketch. We're going to use the offset option on the project to sketch command to offset the edges by 2 millimeters. So I simply select on the edges that I want to offset, and by moving the cursor I can point inside or outside depending on which direction I want to offset. In this case, on these holes I'm pointing to the right, so it offset outside. So what this then does is creates an internal region that I can use to either add material or cut away. And I want to cut it away just 1 millimeter deep to add an indentation into the part. Next thing I want to do is I want to take that cutout and I want to mirror it to the other side. So I'm going to use the mirror option after I select the cutout from Pathfinder, and I'm going to turn on the top reference plane, which I know is directly in the middle of the part. What that's going to do is allow me to mirror it to the opposite side, so it'll have that same indentation on the top and on the bottom. Go ahead and turn off the plane again. Next I'm going to use the project to sketch command again, and I'm going to select the plane that is the cutout down in the face of the cutout, and again I'm going to using an offset. This time I'm going to offset 3 millimeters, and I only need to do this on one of the ears. So I'm going to offset to the outside, I'm going to offset the center hole to the outside, and then I'm going to offset the inside cutout to the inside. And that gives me a region then that I can use to cut away material between the two holes. We no longer need the sketch, so we can hide the sketch, or in fact we can actually delete the sketch. Now of course we want to replicate that cutout to the other two ears, so just like before we can select the cutout and use the pattern. So we want to create another circular pattern just like we did with the ears. We just touch the edge of the circle so it jumps to the center, and of course there's a count of 3, so it adds it to the other two arms. Again, we want to remove all the sharp edges on this part, so we'll go back to the round command and we'll use a couple of different options. Instead of using the face option, this time we're going to select all the rounds and all the fillets. So we're going to add a 0.25 millimeter, just enough to break the edge, to all the fillets. And if we do the same thing to all the rounds, all the outside edges, the entire part will be rounded and have all those edges broken. So it's really starting to look unique. But what would make it really unique is to have 6 arms instead of 3. That's really easy to do with synchronous technology and Solid Edge. All I have to do is wait for Quick Pick, and one of the options I'll have is the design body. So I'm able to select the entire design body and then move the steering wheel to the center of the center hole, and we're going to use the copy option and click on the torus to initiate a rotation. And I want to rotate the entire design body 60 degrees upon itself, and it will boolean those together into a single part. Now that looks cool. Now before we save the part, we need to go back into the file properties to annotate this as a different part, as another revision. So we'll just go back to the Info tab, to the File Properties. We're going to go to the Project tab, and we're going to assign it to Revision B. And then we can go ahead and save the part. So now we know that we have the second version of this part. Now we want to 3D print this, so we actually want to build this. So if we go to the 3D print under the application button and go to the preview, it shows you the size of the part, how it's going to look in the 3D printer, the orientation. We can also go to the export options for the STL file, and we can change anything we want to change there. And then when we're ready, we can go ahead and just export this as an STL file that we can send to our 3D printer. If you don't have a 3D printer, you can select Order Online, and it will actually send that to outsource this to a service, and it will actually come back and give you prices depending on the type of material that you want to make it out of. So anything from plastics to metals, it will give you a price on what it would cost. You can go ahead and order it, put in your credit card, and within a week or so you'll have your part. So if we come down here right now, it's set to all. We just want to look at plastics. So when we set this to plastics, you can see the prices that it's giving you depending on the type of plastic. PLA is the most common. You can see it costs you $30 to get one of those made, 3D printed based on the size. All right, so with that, we'll go back to the part. Let's go back to the assembly. We'll just close out of the part file. And of course, you can see that the bolt and the nut has not been populated to those new holes that we created. So using the same method, we'll select the bolt and the nut. We'll click the copy option. We'll make sure the steering wheel is on the center of the bolt. We'll drag it to the new location. It will snap to the hole. We'll lock it in, and then we just need to select the part to reestablish those relationships to the plastic part. And of course, we just need to repeat that a couple more times to get the rest of the bolts and the nuts in the right position. That's going to add a lot of weight, which is going to make this thing spin really well and for a really long time. All right. Again, we can animate. You can see how the fidget spinner is going to look as it rotates. And then this also needs to be set to revision B. So we'll go to its info, file properties, project tab, and we'll set this also to revision B. And then we'll go ahead and save the assembly. And we need to return back to the drawing and see what that looks like. We go back to the drawing, it's telling us that there's something out of date. So we go ahead and click OK, and then we need to update the views. And when we do that, Solid Edge tells us what has changed. It'll give us this revision, so anything that's changed, it will show us, whether it be a dimension or whatever the case may be. Here we may need to adjust our balloons because now we have a much bigger fidget spinner, still the same alignment shape. So I'll just adjust the balloons and adjust the arrows around so they make more sense and they're easier to find. We'll adjust this to an outside edge of the spinner part itself. And it's still all associative back to the parts list. Also notice the quantities have changed. The revision letter has changed on the plastic part to B, and the quantities have changed for the bolts and the nuts, which makes sense. If we go back over to our part, you can see now that we have a section view that's going all the way through the part, and that's been changed as well. I need to lengthen the line, so I'm going to edit the section line. I also want to make sure that it's still locked to the center, so I'll connect the midpoint of the line to the center of the hole. And then again, we'll set the direction, and then we'll just simply need to update the section view. And now you can see that it's completely changed, that you can see the cutout areas. You can also see that we need another center line for the bottom hole that we added. You may also want to add a bolt circle to the front view. So that's very easy in Solid Edge. You just simply select the bolt circle command, pick on the center for the bolt circle, and then one hole, and it will automatically find all of the holes that fall on that bolt circle and add the appropriate center marks that point toward the center. A detail view is also common to make it easier to dimension fine details. Makes an enlarged view. It's just 3 mouse clicks, one for the center point, one for the size of the detail view, and one to place it on the drawing sheet. So this makes it easier to detail very small details like this 1 millimeter round on the corners, or even smaller, the 0.25 millimeter rounds that we added last to the fillets and to the rounds. So it makes it much easier to see what you're detailing. So we can continue to add smart dimensions to detail out all of the detail of this part, maybe the depth of those cuts. You can See, there's a 1 millimeter from each side. And you would just continue to add the details to that manufacturing drawing so that it could be manufactured, picking up all of the whole information, the rounds, all the information needed to actually manufacture this part. So that concludes this solid edge tutorial of the fidget spinner. I hope you enjoyed it.